In this video, you're gonna learn how to write a double displacement, single displacement, and combustion reaction. So let's first start it by looking at double displacement. Double displacement is simply switching the cation so that you have like different compound at the end of it. So in here, you can see that AB plus CD go to AD plus CB, right? So what happened is A and C represents a cation, and then B and D represent the anion. So what happened is when the cation switch, or you can switch the anion, doesn't matter which one you switch, your new pair is gonna to be 1 plus 1 minus, one of them plus, one of them minus. Okay, do not put the both plus ion together or both anion together. Okay, so in this case, you can, like I said, you can switch cation, anion. Here we said we're gonna switch the cation. Cation is the ion that write first in the ionic compound, usually speaking. Ionic compound are neutral, meaning zero net charges, so make sure your charges are zero, and then you're gonna balance the chemical equation. So let's get started. Let's see what's happening. So first thing first, I am going to write down these iron first. So you have Ag, NO3. So if you think about it, Ag is plus 1, NO3 is minus 1, NaCl, Na is plus 1, Cl is minus 1. So what's going to happen is we're going to switch them. So we're going to switch Ag and Na. So these two is going to simply get swapped. So that in this case, the new pair that you're going to get, is going to be NaNO3 and then AgCl. And that's it, because in this case, plus 1 minus 1 plus 1 minus 1 charge even out, and also the equation is already balanced, so you don't have to balance this. Let's look at the next one. The next one is lead 2 nitrate. I know it's 2 because the nitrate is minus 1 charge, so lead in this case must be plus 2 charge. Again, so I'm going to write it a little bit differently. Pb is plus 2. I'm going to also write the Cu so that you can see what I'm talking about. Here you have these two, and then we're going to say NO3, which is minus 1, and then SO4, which is minus 2. Again, we're simply switching these two, Pb and a Cu. So these two are going to get switched. So then the answers is going to be Cu, go with NO3, and then Pb is gonna go with, SO4. Okay. And then now what happens? You have to think about their charges. We just said plus 2 minus 2, so this is good. Plus 2 minus 1, this is not good. We need to balance that. So that means I'm gonna put the parenthesis and then 2 right there. Now I'm gonna put plus between the two compound. And then next I had to balance the individually. Take a look. 1 Pb, 2 of the NO3, right? 1 Cu, 1 S, 3 of 4 O, plus there is also 6 here, right? So if you think about O, that's how it is. So in this case, happen to be these both cases, the equation already balanced. Let me try to find the one that is not quite balanced. So I'm going to do 2 more before I move on to the next session. So I'm going to do 3 for us. So let's go ahead and take a look at 3. So what would I do? Again, I'm simply switching CD with the NH4. Okay, so I'm going to write NH4, and then I'm going to write PO4. Okay, leave it aside, we're not done yet. And I'm going to write CD with the S. Okay, here's the thing, moment of truth. You got to think about what is their charges. Based on here, we know that PO4 is minus 3. Since there are 2 of them, that's a total of minus 6. CD has 3 of them, so that means that is actually plus 2. So I know CD is plus 2. NH4 is plus 1, S is minus 2. So here we can see this is plus 1 minus 3. So I do need to put like this, make it 3. So plus 1, right? Times 3, so plus 3 minus 3. CD is plus 2, and then this is minus 2, so we're good. Okay, so are we done yet? We're not, because we need to balance the chemical. I don't know that. So we get 3, so we're going to say 3. Okay, so that's done. PO4 is 2. Let's take a look. That is PO4. Another hint is you can count the polyatomic ion as together if their element is not seen somewhere else on the equation sides, then that's fine. But in this case, it doesn't, so I'm gonna start with that, and I'm gonna go ahead and count it like this. Okay, so in this case, there's 2 of there, so I'm gonna put 2 there, which make it 5. Let's take a look. NH4, there's 3 of them, and then there's 2 of them, there's 6 of them. NH4 is here, only 2 of them, so I'm gonna put a 3 in front of this. Okay, which means the S is now 3, there's a 3S. Okay, so we are good. We did it correctly. Now, if you want, you can go back with a pen and then mark them because we got the correct answer. Okay, we did it. All right, let's go ahead and take a look at another one. I'm gonna do this one. Again, we're just gonna simply switch these 2 iron. So Na is gonna go with OH, and then Al is gonna go with C2H3O2. The key is think about what is their charges. So do not start writing yet, think about their charges. Na is +1, OH is -1, so we're good. This one, Al is +3, and C2H3O2, that's an acetate, that's a -1. So I do need a parenthesis, and then put the 3 there. Okay, once you're done, you're gonna balance it. So I wanna say that would be 3 here, and then 3 here, and I think this is balanced. So we're balanced, okay? All right, I'll do one more. Take a look at the next one. We're switching these two, Al and Ca, okay? So Ca is gonna go with SO4. Al is gonna go with PO4. Now, check the charge first. +2, -2, this is good. +3, -3, so this is good also. Let's try to balance this. There's 2 there. I'm gonna put 2 there. PO4 is 2, that's great. C is 3, SO4 is 3. Let's put 3 there. We're good. Okay, so this is how you would do double displacement. Let's take a look at the single displacement. Single displacement is a little strange. Single displacement is dependent on the singles. So you have 2 possibilities. You either gonna replace a cation or you're gonna replace the anion. So in this case, that's what they will say. There's 2 possibilities. So check the possible charge of the free element. I mean, this is an element that is standalone. The standalone element, whether it not necessarily want to be, whether it tend to be, I guess, to form cation or anion, right? And then you replace that free element with the normal, either cation or anion, whatever that is supposed to be. Make sure it's a 0 net charges at the end, and then make sure you're careful about diatomic. If it's diatomic, don't forget that the new free element must be written into. So H2, N2, O2, F2, Cl2, Br2, I2. Remember that one, diatomic, if there is diatomic. And then of course you balance the equation. So let's look at 2 examples. Mg plus ZnNO3, 2. Okay, Mg. Mg, what did Mg usually do? This is the metal. So that means metal is cation. And in fact, this is +2. So that means it's going to take the Zn space. So Zn is going to be alone, and Mg is going to be NO3. In this case, both Z and Mg are +2. Zn is also +2. So that means NO3 in this case is like that. It is already balanced left-right, we're good. And also Zn is a metal, it's not one of the diatomic, we're good. Next case is Cl. Cl is non-metal and it's still -1. That means it's gonna replace that Br spot. So that means Br is alone, and then Na go with Cl. Now, remember, you gotta check the alone guys. This is a diatomic, so that means Br has that 2 there. Now we're gonna balance this. Right? Okay, let's go to the next one. I'm gonna do 2 more questions so that we can kind of check what's going on. Okay. Usually for this one, they will tell you what sort of Cu is. Since they're not telling you, we can, so this question probably won't ask because they will tell you what kind of copper gonna form, because copper could be either +1 or +2, and it does make things a little bit complicated. So I'm gonna just assume we're gonna deal with copper 1 sulfate and iron, which is Fe. Of course, you can also do copper 2. That means that I'm gonna use copper 1 as in this example to write, okay? So we're gonna have copper plus FeSO4. So copper 1 will be CuSO4. Then I will need to put 2 there because that's +1 charge, that's a -2 charge, right? Again, I picked copper 1 for a reason because I want to show you that you need that little 2 there to balance out the charge. Okay, so that 2 is not that number, that 2 is a charge. That's 2 is balance the charge. That's 2 just mean that there are 2 copper there. Okay, iron, Fe. Okay, now that I have that, I'm gonna balance this. We're done. Okay, so let's do one more question. Let's do the first question. Zinc and then AgNO3. So this is kind of similar to the, oh, sorry, you can see. Let's do the first question actually. Aluminum and then H2SO4, yep, like that. This was a little bit strange again. Again, we're gonna deal as is because aluminum is +3, this is +1. I'm gonna use it as this, right? SO4 is -2, so I'm gonna use it like that one. So we know that aluminum will take the H spot, so we're gonna get Al with the SO4, and then H is a no. Again, we're just practicing, so this equation might or might not happen, but we're practicing writing these. AlSO4, Al is +3 charge, this is -2 charge, so therefore I'm going to put 2 there. SO4 is polyatomic, so I need parentheses, and then 3 to balance it. This is a diatomic, do not forget. Okay, now you're going to check to balance out the charges. The left, right. So you see there's 2 Al, there's 3 of the SO4, so let's go ahead and do that. 3, 2, which makes 6 of the H. So put 3 there, 6 of H. We're good to go. Okay, so this is how you're gonna do single displacement. Next one is combustion. So let's take a look at it. Combustion is always some kind of hydrogens and carbons and sometimes oxygen. Some cases there is oxygen, and then they're always reacting in oxygen, and then you're always gonna make these two as a product. Okay, this is the reactant. This is the one of the reactant always. That is the combustion analysis. So let's take a look. C3H4O3 under one combustion. Well, C3H4O3. If it under one combustion, you just say plus O2 go to CO2 plus H2O. Then what happened? We're gonna balance this. 3, 4, so that's 2. Then now I'm gonna count it. 3 times 2 is 6 plus 2. So that's 6, 7, 8. Okay, so we're 8. There's 3. 8 minus 3, we gotta make 5. I can't make this 5 because it's 2 there. So guess what happened? This is why you use pencil, because now I had to erase these two numbers and increase them by 2. So I need to double that. So this will become 4. This will become 6. This will become 2. Now we check. 6 times 2 is 12 plus 4, 16. 2 times 3 is 6. 16 minus 6 is 10. This has to be 10. There's 2 there, so I'm going to put 5, which makes sense. Okay. Let's go ahead and try one more. Let's go ahead and try one more. We're going to go ahead and try this one. C3OH. CH3OH. Okay, oops, I almost make a mistake. Combustion is always added with oxygen. Without oxygen, it won't burn. CO2 and water. 1C, 4, 1C, 4. Let's count. 2, 4. 1 there already. So that means I need to make this a 3. Again, not possible. Let's double it up. 2, 2, 4. Let's count. 4, right? Plus 4, that's it. 8. 8 minus 2, that's 6. That's 2. 3 then. 3 times 2 is 6. Got it. Okay. What wrong with this combustion? Missing O2 as reactant. Okay, you always need oxygen. Okay, this is just double displacements. You can see here. I give you example. Oh, this is wrong on that one. I don't know if you guys can tell. Oh, wait, you can see. 2, 3, 4. Kind of give you these. You have to figure out the error. Oh yeah, this is why they said these are error. So you gotta figure out what is the error. Some of the error are because the answer are written wrong. So again, from this to this, you're finding error. Identify the error, right? Identify the error. So we have done the number 1, right? So let's take a look at the next one. What wrong with this? Okay, this one, not much, right? CaNO3, Na2SO4, switch. You're gonna have Ca go with SO4 and then Na go with NO3. Look like right, except this one. You never do this. You always put the cation first instead of anion. CaSO4, not the other way around. Okay. And then when you finish, you should also balance it because there's 2 Na and there's only 1 Na. So that's wrong. We got to balance that one. So yeah, so those are the stuff that is you need to change it. Okay, watch out for this. Okay, so that's what I'm gonna say, and then just rewrite me the correct equations when you finish them. So that's for the rest of the question from number 1 to 13. Number 1 to 13 is you're just basically finding error. Actually, number 13 is the same question, so you can take it out. Actually, number 13 is the same thing as number 4, so you don't have 13. You're only doing it up to 12. Okay, so 12 questions. All right, so the homework, same thing. You're just doing double displacements. Some of them I forgot to make it subscript, but they're the same. You're just trying to figure out. These at the back, it doesn't tell you whether it's double or single. You can tell. Like for example, this one, they both are, they both are compound. So that is the double. So K is gonna switch with Cu. Okay. This is gonna be single because you only have Cl. But Cl is a nonmetal, so it's gonna switch with I. Okay. Again, this is a double, 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 single, 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 right? So you just want to make sure so that you know how to do it. Okay, so that's pretty much it. Make sure you try these. I'll give you answer key to this later.